event in the background, and you can see that this is going on right now. So I'm going to press continue after we have fetched the attendee count from the database, and you can see that this is free. And now I can query the event statistics from the database, update the attendees checked in property, and replace this document inside of MongoDB. Now that we are back in Postman, let's go ahead and send this request again, and this should trigger a duplicate check-in. You can see that we get back a response of a duplicate check-in, and our Outbox processor is working in the background, so it's going to trigger on the duplicate check-in attempted domain event handler. And let's go ahead and execute this, and this is going to update the collection for this document and include the ticket code for the duplicate check-in. So let's go ahead and press continue. So now I'm going to specify the ticket ID that doesn't belong to the current attendee. So if I send this request, I should get back a 400 byte request that says invalid check-in, and you can see that my Outbox processor is working in the background. So let's execute this domain event handler and press continue. And now if I try to query the event statistics, you will see that it includes a lot of additional information. Now we have some values in the duplicate check-in tickets collection. We also have some values in the invalid check-in tickets, and the attendees checked in count is also updated. We didn't yet update the tickets sold because none of these events has triggered. Now let's go into Jaeger and check out some distributed traces. I'm going to take a look at the trace for the get event statistics endpoint, and if I take a look at the latest trace, we can see that we have our initial query that's going to check the user's permissions. This is not what we are interested in, but this query looks interesting because it's executing the event statistics find operation on our MongoDB instance. And here you can see the database statement that is being sent to MongoDB, and this is a find operation on the event statistics collection, and then you can see the filter that is specified, which is looking for a document with this identifier. We are able to see this span inside of our distributed trace thanks to the OpenTelemetry library that we installed. Let's also check out the health checks endpoint. So if I send this request, we should be able to see MongoDB inside of the health check results. And if I go ahead and manually stop our MongoDB instance from Docker desktop, and I send the same request to the health check endpoint, this time you're going to see that it's taking a few moments to give us back the response. And you can see that we get back the response after about 30 seconds, which I assume is the default timeout for MongoDB queries. And if we go to the MongoDB health check, you can see that the status is unhealthy. If I go and start up the MongoDB instance manually again and send the request from our health check endpoint, I expect that we should be able to connect to our MongoDB instance, which you can see is the case, so we can conclude that both OpenTelemetry and our health check is working with MongoDB. Now I want to show you one more interesting use case that opens up with the use of MongoDB, and I'm going to introduce a new type into the event statistics folder. This is going to be my ticket model. This type will contain additional information about a ticket, and I'm going to use it from the event statistics class and update my duplicate check-in and invalid check-in collections to have a ticket model type instead of a string. Then I will also need to update the respective projections to insert a new instance of the ticket model, and I already have all of this information present on the domain event. So I can say attendee ID is domain event attendee ID. Let's also specify the event identifier, the ticket identifier, and lastly the ticket code. Let's also apply this in the invalid check-in projection, where we have the same information available on our domain event. And now what we can do is to start the application, go into MongoDB, and remove the document that contains the old values. Then we're going to replay our Outbox messages, which is going to run our projections again and produce an updated document inside of MongoDB. So I'm going to manually delete this document from my MongoDB database, and I'm going to make an update to my Outbox table behind the scenes that's going to cause my Outbox messages to be reprocessed again and our projections to execute one more time. After a few moments, our projections should execute, and if I query this collection again, you can see the updated value of the same document that we had before. So this is our event statistics document. I also made sure that the ticket sold property was updated. And now if I open up the collections for duplicate check-ins and invalid check-ins, you can see that it contains an object inside, where we previously had just a string value. And this now contains the attendee ID, event ID, ticket code, and you can imagine how easily we can continue expanding this document with additional information because MongoDB is schemaless and we have complete freedom of what we want to store inside of a collection. If I send another request to get the event statistics, you will see that we get back the updated response that also contains the ticket models in the duplicate check-in and invalid check-in collections. And we can slowly wrap up this lesson about using MongoDB for persisting data on the CQRS read side. Because we have an event-driven architecture in place and we are using the event notifications pattern, it's relatively straightforward for us to introduce read side projections. Inside of these projections, we can gather any data that we need, and we can persist this data inside of a single document in MongoDB, which allows us to easily query this document and return it from our API. Because MongoDB is schemaless, we also have complete freedom into how we want to evolve the structure of this document. This concludes our mini course about implementing CQRS with MongoDB inside of the modular monolith architecture. We used read side projections to produce an optimized query model that satisfies a specific query inside of our application. And I think this demonstrates how flexible a polyglot persistence approach can be when building a modular monolith. Thanks again for watching this mini course, and I will see you in the main modular monolith architecture course. Congratulations on completing the bonus mini course. I hope that you enjoyed it, but don't forget that you still have more than 11 hours of valuable information inside of the core modular monolith architecture course. If you enjoyed this mini course, I'd like to invite you to do two simple things. The first one is to go ahead and leave a testimonial and share your review about this course, and you can do this from the testimonial form that's going to be right under this video. You can choose between leaving a video testimonial and a text testimonial. I'm going to share these testimonials on my website that gets more than 1 million views every year. Secondly, I'd like to invite you to join my affiliate program, and you will find the link for the affiliate program also under this video. In the affiliate program, you will get a unique link that you can share with your friends, colleagues, on social media and on your website, and you will get 25% out of every sale that you make. This concludes the bonus mini course, and if you'd like to learn more, I invite you to check out the core modular monolith architecture course. Thanks a lot for investing your time, energy, and attention, and I appreciate you being both a customer and a student. I'll see you inside of the core course, and don't forget to stay awesome.